Hello everyone and welcome back. In this video we are going to learn about type 2 improper integrals. In the last video we learned about type 1 improper integrals. Okay, so here's my example. Now this time you want to integrate the function 1 over x with respect to x for between the x values 0 and 5. Now if you look at initially at the bounds of the integral, that means 0 and 5, there's no problem with 0 and 5. At least this is not a type 1 improper integral, right? Because there's no infinity in the bounds of the integral. Right. Now let's talk about the function 1 over x, because the function 1 over x is a very interesting function, because when x is equal to 0, this function is not defined, because when x is equal to 0, that means the new denominator is 0, then that means you are dividing by 0, and that's a big no-no. Or if you remember your pre-calculus class, you know there is a vertical asymptote at x is equal to 0 for this function. Meaning, think about the behavior of this function. Now, if you think about really tiny x values that are closer to 0, tiny positive x values like 0.1, 0.01, 0.001, 0.4071. So when each time you take a really tiny positive x value, you are dividing by a tiny x value, so that means the value of this entire fraction is really large, right? So the function shoot up to positive infinity, right, along the line x is equal to 0. Now if you think about the right hand side, now if you think about x values that are really small and negative, like negative 0.1, negative 0.01 likewise, then the function shoot up to negative infinity, right, when you take really tiny or really large, I should say, negative x values, right? However you want to think about it. So this function, we say for this function there is an infinite discontinuity at x is equal to 0. If it is too much for you, just see that this function 1 over x behaves very badly when x is equal to 0. Okay, all right, so that's the problem with this function. But however, what's the problem with integral? The problem with integral is that yes, the function is very bad at x is equal to 0, and do you see 0 somewhere else? Yeah, 0 is the lower bound of the integral, right? And that's the problem. Not just the function behaves badly, the point that the function behaving badly, it is part of the integral. That's the problem here. Okay, right. Now let's think about this geometrically. So 0 and 5, I have marked them here. Now you want to find the area of the region. By the way, this is 1 over x graph of 1 over x, okay, this ugly looking graph. Apologies for my drawing, but this is 1 over x. Now you want to find the area of the region that I mark here, that I highlight here. Now there's no problem with the lower boundary because it's finite. 0, between 0 and 5, it's finite. But the y-axis, along the y-axis, you can see it seems to be like the region is extremely large, or it's going on forever at least, right? Not extremely large, but it's going on forever, right? So again, it's impractical to talk about. Someone might think that it's impractical to talk about area of this region. Okay, right. Now let's think about another example. I'm going to take the same function and I'm going to change the bounds of the integral. Let's go from negative 2 to 0. Again, is this a type 2 improper integral? Yes, this is another type 2 improper integral, because again, now it's not a secret that 1 over x behaves badly at 0, and 0 is part of the upper limit of the integral, or the upper bound of the integral. Now you can see in both of these cases, in both of these integrals, the bad point is actually part of either the lower limit or the upper limit of the integral, which because of that we say both of these integrals are type 2 improper integrals. Okay, versus if you think about type 1 improper integrals from the previous case, it's just in a type 1 improper integral, write it in front of your eyes, you see infinity. But in type 2 improper integrals, you don't see it right away. The infinite discontinuity is hidden. Okay, you will not see infinity or negative infinity explicitly. It's just you need to work it out. So here's my hint. How would you identify a type 2 improper integral? First, look at the function. Okay, forget about the bounds. First, look at the function. Think about all the bad points of the function, the points that the function behaves badly. Figure them out and see whether those points are part of the bounds of the integral or not. Okay, all right, now don't click out of the video because we need to discuss two more cases. All right, here's my next example. The same function, now you're integrating from -2 to 5. Okay, how do you figure out whether this is type 2 or not? Look at the function. 1 over x, fine. Now we know 1 over x is not defined for x is equal to 0. Okay, so 0 is a bad point. Is 0 part of the bounds of the integral? No, 0 is not -2, 0 is not 5. So, do you think this is a type 2 improper integral? Yes, still this is a type 2 improper integral. Why? Now 0 is not one of the limits, but it's in between the limits of the integral or the bounds of the integral. So 0 is in between -2 and 5. That's the problem here. Now think about this geometrically. So here's my -2, okay, and if you want to find the area under the curve 1 over x between -2 and 5, you still have to go through this bad region, this bad patch, right? So still this is a type 2 improper integral. Okay, again let's try to summarize before we go to the next example. How do you identify a type 2 improper integral? Well, first look at the function, see whether the function behaves badly or function has an infinite discontinuity at a certain point, and see whether that bad point is either the lower limit or the upper limit, or if that point is in between the limits of the integral, then it's a type 2 improper integral. Okay, here's my final example I promise you for this video. 1 over x, same function. Now you are integrating from 6 to 9. Now tell me, pause the video and think, is this a type 2 improper integral? Nope, this is not a type 2 improper integral. Reason is that I know the function is discontinuous when x is equal to 0, but is 0 a part of the bounds of the integral? 0 is not 6, 0 is not 9, and 0 is not a number between 6 and 9, right? Now think about this geometrically. So you want to integrate this function now from 6 to 9. So that means this tiny region. And that tiny region is bounded from everywhere, a tiny enclosed region, far away from this bad region, right? So, or you might say this region right here has skipped the bad part or the bad point. So, because of that, this is a proper integral. This is not an improper integral, not a type 2 improper integral. So you have to be little bit careful. Yes, your function is discontinuous, but the point that the function discontinuous has nothing to do with the limits of the integration. Okay, so then it's not a improper integral. All right, so that's how you identify type 2 improper integrals. So let's do a quick summary before we go to the next video. Okay, type 1 improper integrals, how do you identify them? Well, if you have infinity or negative infinity or both in the limits of the integral, there you go, that's a type 1 improper integral. How about type 2 improper integrals? You have to do a little bit of work here. First, look at the function. See whether the function has an infinite discontinuity, or that means if the function is undefined for a certain x value, classify that value as a bad point. think it as a bad point. Now see whether that bad point is actually a part of the lower limit or the upper limit of the integral, or at least see whether that bad point is in between a and b or not. Okay? If that bad point is either the lower limit or the upper limit, or if it is in between a and b, then it's a type 2 improper integral. But be little bit careful. Your function may be discontinuous, may behave badly at certain points, but if that point has skipped the bounds of the integral, then your integral is proper, then your integral is totally fine. Okay? Right. Now, you know what we are going to do in the next video? Let's take 10 integrals and see whether we can classify them as type 1 or type 2 or neither, or proper. Okay? So let's do that exercise in the next video, and I will hopefully catch you in the next video. Thank you.